In this video, we have a look at true bearings. How do we use true bearings to help us draw a diagram from a word question and help us to work out the answer to that word question. True bearings are measured in the clockwise direction from the north-south line. So if we were to calculate the size of the angle using true bearings, we would start at the north and work our way around till we got to the direction that we were traveling in. So therefore, our true bearing measurements will range from 0 up to 360 degrees. When we are writing true bearings, we always use 3 digits when we are writing our angle and finishing off with degrees and then a capital T. So for example, if the size of the angle we were measuring was 30 degrees, our true bearings would be 030 degrees true north. So remembering if it is under 100 degrees, we need to put the 0 in front. So we are maintaining 3 digits. If our angle size was 260 degrees, we'll write it as 260 degrees true north. So let's have a look at an example of how we can use true bearings to help us draw a diagram and to answer a word question. So in our example, a boy walks 2 kilometers on a true bearing of 90 degrees and then 3 kilometers on a true bearing of 130 degrees. And then there's a few parts to calculate based on that information. So before we have a look at those individual parts, what we're going to do is start off with drawing a diagram, and that is going to help us answer each of those 3 parts of the question. So looking at the information, I know the boy walks 2 kilometers and a bearing of 90 degrees, and then he walks 3 kilometers on a bearing of 130 degrees. So I can use those 2 pieces of information to be able to draw my diagram. So we have a starting point of our boy, and he's going to walk 90 degrees north. So before I can calculate his walk, I need to add in a guideline. So that is going to be up there, and 90 degrees north is going to be straight on a right angle, and that is going to be for 2 kilometers. Then the boy works another 3 kilometers, this time using a true bearing of 130. So again, I need to add in my north guideline. And this time he's going to walk 130. So that is going to be 90 degrees horizontal and then an additional 40 degrees down into this direction. And that is a 3 kilometer walk. And the boy ends up at this point down here. So we're going to label our points A, B, and C. So we now have a diagram with the boy's walking path, and that is 2 kilometers, 90 degrees true north, and then 3 kilometers, 130 degrees true north. So now that we have that walking path, we can go ahead and calculate answers for A, B, and C. So for part A, we want to calculate how far east from the starting point the boy is at the end of his walk. So how far east that is going to be. His starting point was at point A and ended up at point C. So the east direction is from point A to point C in a horizontal line. So we brought our point A down, and that is going to be how far east the boy has walked. Now, to be able to calculate how far east the boy has walked, we can use trigonometry if we can form a right angle triangle. So having a look, we can form a right angle triangle by splitting our total east direction line up into 2. So we can split it down here, and that means we have formed a right angle triangle that I can calculate the distance from that point across to the C. So I'm going to call that X, and then I already know that the rest of the line is equal to 2 kilometers. So if I can work out what X is, I can work out the total distance he has traveled east. So to do that using trigonometry, I need to work out an angle value, and I know I can work out this angle value up here because I know from here across down to there is going to be 130, and from there across to the straight line is going to be 180. So my angle is going to be 180 minus 130, which is 50 degrees. So I know that this angle up in here is going to be 50 degrees. So using trigonometry and the specified angle, I've got an opposite side and a hypotenuse side. So I'm going to use the sine rule. So sine of the angle is equal to opposite over hypotenuse. So sine of 50 is going to equal to x over 3. So my x is going to equal to 3 times sine of 50. So using a calculator, x is going to equal to 2.3 kilometers. So to work out my total distance, it is going to be 2 plus 2.3, which is 4.3 kilometers. So the boy has traveled a total of 4.3 kilometers east from his starting point. So now having a look at part B, and we want to calculate how far south the boy is from the starting point at the completion of his walk. So we're going to work out the distance between point A and point C if it was in a straight line south. So to be able to do that, we can use trigonometry if we can form a right angle triangle. And instead of using point A, we can use point B and draw a line straight down and then across to C. And then that is going to give us a right angle triangle we can use. Now the total distance south is going to be along the side of that triangle. So we'll call that Y. And from part A, I know that this angle in here is going to be 50 degrees. So now I can use trigonometry and I have got the hypotenuse side and the adjacent side. So I can use the cos. So cos of the angle is going to equal to adjacent over hypotenuse. So cos of 50, substituting in my values, is going to be y over 3. So y is going to equal to 3 times cos 50. So putting that into my calculator, I know that y is equal to 1.9 kilometers. So the boy is 1.9 kilometers south from his original starting point when he finishes the walk. So having a look at part C, and we want to know to return directly to his starting point, how far must the boy walk and at what bearing? So what the question is asking is to go from C to A in a straight line, what is that distance going to be? And we will call that distance D. So to work out D, I can use Pythagoras because I can form a right angle triangle by joining up from A down to in line with C and across to C. And I know from my part A calculation that my bottom of the triangle is going to be 4.3. I know the side of my triangle from part B is going to be 1.9. So I can use Pythagoras to complete that calculation. So because I'm finding the hypotenuse side, C squared is equal to A squared plus B squared. So substituting in my values, D squared is going to equal to 4.3 squared plus 1.9 squared. So D squared is going to equal to 22.1. So D will equal to the square root of 22.1. So my D value is going to equal to 4.7 kilometers. So if the boy was to walk in a straight line from point C to point A, so from where he is back to the starting point, it will be 4.7 kilometers. So now to finish part C, we need to go back and work out what that bearing is from point C to point A. So to start calculating that bearing, I'm going to add in my north guideline. And the bearing is going to be from that north guideline around to hit my direction of travel. So I need to work out what that angle is going to be, and I'm going to call that angle X. To help me to work out angle X, I want to work out what my angle is that will allow me to complete my 360 rotation. I'm going to call that angle Y. And to do that, I can form a right angle triangle and use trigonometry. So I can form a right angle triangle. I know that the top side of that triangle from part A is going to be 4.3 kilometers. I know that the height of my triangle from pad B is going to be 1.9 kilometers. So using trigonometry, I've got an opposite side and an adjacent side. So I can use tan to find out the size of my angle y. So writing the formula, tan of an angle is equal to opposite over adjacent. So tan of angle y is going to equal to 4.3 over 1.9. So my y value is going to be the inverse of tan, 4.3 over 1.9. So my y value is going to equal to 66.16 degrees. So now that I know my y value, I can calculate my x value, my true bearing value, and that is going to be 66.16 plus x is equal to 360. So x will equal to 360 minus 66.16. So my angle x is going to be 293.84 degrees. So the bearing the boy must walk to get from his point where he finished back to his starting point is going to be 294 degrees true north, and I've rounded up to the nearest degree. So that is an example of how we can complete calculations using two bearings from a word question.